Hello, grade 8 students. So welcome to our electronic module, lesson 1, entitled Factoring Common Monomial Factor. So we all know that factoring is the inverse of multiplying, right? So in multiplication, you find the product of the given factors, while in factoring, you find the factor of the given product. So I think you're excited. So let's proceed to the next part of this presentation on how to factor a polynomial with a given monomial factor. Okay, for this example number 1, so we need to find the possible factor of 24. So what are those possible factor of 24? So it may be possible factor of 4 times 6, which is equal to 24. So another possible factor of 24 is a 3 times 8, so which is equal to 24. Another factor of 24 is 2 times 12, so which is equal to 24. And then the possible factor also for 24 is 1 times 24, so which is equal to 24. But also there are possible factor of 24 aside from these positive integers. So we have negative 4 times negative 6, so which is equal to 24. Next is negative 3 times negative 8, which is equal to positive 24. Then negative 2 also times negative 12 is equal to positive 24. And lastly, negative 1 times negative 24 is equal to positive 24. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible factor of 24. So therefore, we can have 8 possible factor of 24. So let's proceed to the next presentation. So to factor a polynomial with a common monomial factor, so here are the steps in order to factor a polynomial. So first step is that we need to find the greatest common monomial factor, or the GCF. And then second is we need to divide each term by the common monomial factor to get the other factor of the polynomial. So let's have an example. Number 2, to apply these steps in factoring a polynomial. Okay, so let's have example number 2. So we need to apply the 2 steps in factoring a polynomial with a common monomial factor. So we have step 1. So we need to find the GCF from the given example number 2. So first, in order to find easily the greatest common factor of the given expression, so look first for our numerical coefficient, the common factor for our numerical coefficient. So our numerical coefficient from the given expression is 2, 4, and 6. So I think the common of the 3 numerical coefficient is number 2. Then for our literal coefficient, so simply find the possible common of the 3 literal coefficient, the ax, ay, and az. So letter a, letter x, letter y, or letter z. So therefore, The common literal coefficient for this example number 2 is letter A. Okay? Is letter A. So let's proceed for step 2. So for the step 2 is we need to divide each term by the common monomial factor in order to get the other factor of the polynomial. Okay? So we have 2a for our GCF for the step 1. So simply for the step 2, simply copy the given example number 2, 2ax plus 4ay plus 6az. So therefore, we need to apply the step 2 by divide that we need to divide the greatest common factor for these terms. So we need to divide 2x divide 2a, 4ay divide 2a, then 6az divide 2a. So simply equals, so we need to divide 2 divided by 2 is equal to 1. So we need to cancel out. Then 2a later a divided by a is cancelled out also. So therefore, we have x plus, next 4 divided by 2 is simply, that is 2. 3 is 1. So therefore, the answer is 2. Then a divided by a is also cancelled out. So therefore, ang nabilin is 2y plus, okay, 6 divided by 2. So that is 3. So simply copy 3. Then a divided by a is cancelled out. So therefore, the remaining terms from the given expression is 3z. So we have x plus 2y plus 3z. So simply, we need to equate, or we need to find the given factors. So we have the GCF, which is 2a times x plus 2y plus 3z. So therefore, the factor for example number 2, which is equal to 2a times x plus 2y plus 3c. So this is our answers, final answer. So the factor for our 2ax plus 4ay plus 6az is equal to 2a times x plus 2y plus 3z. So that's it for that example number, okay, number 2. Okay, so let's have example number 3. So given BA plus BC minus BD plus BA. So first, step 1, to find the GCF, or the greatest common factor, for the given example number 3. So since the given numerical coefficient for the four terms is 1, so we have imaginary 1, right? So therefore, directly, the given numerical coefficient is 1, so the factor is 1, the common. So for our literal coefficient, so we need to find the common factor between the BA, BC, BD, and BE. So what is the common between the four terms? Letter B, letter A, letter C, letter D. So the common is letter B. So therefore, our GCF is 1B or B. So they are the same value. Okay. For the step 2, so we need to find the another factor. So we need to divide the given example number 3. So we have BA plus BC minus BD plus BA. So simply, we need to divide the GCF from the step 1. So therefore, we need to, we need to divide each term by this GCF. So divided by letter B, BC over B, negative BD, negative BD over B, then positive BE over B. So therefore, since B over B, so that is cancelled out. So the remaining term for the first term is letter A plus B C over B. So directly we need to cancel out the letter B. So therefore, the remaining term is letter C minus BD over B. So therefore, cancel out B over B. Then the remaining term is D. Then last term is BE over B. So therefore, cancel out the letter B. So the remaining term is letter A. So simply, we need to copy the step 1 factor GCF and then the step 2, which is A plus C minus D plus E. So therefore, our factor for the example number 3 is first GCF, which is letter B, times A plus C minus D plus A. So this is our final answer. So therefore, example number 3, which is 1BE plus 1BC minus 1BD plus 1BE. So our final answer is B times A plus C minus D plus A. So here is our final answer for this example number 3. So I hope you've learned a lot for this example number 1, 2, 3 for uh, factoring polynomials with a given common monomial factor. So good luck and proceed for the next part for this electronic module.